Miniature Steam, Hacks, Hints and Tips, working on Stuart Model's twin Victoria that was bought as part finished. Is it a good idea? This is a longer video than normal, and the job itself took a lot longer than this to do. The first thing that's apparent with this engine is that the main bearings are not split units, and there's a little bit of play on them as you can see here. So I have the choice of whether to make these into split bearings or just bush them. The main steam inlet is a bit of a bizarre construction. It's far too long and it's not threaded far enough down into the T-piece. This is an easy fix, I'll get to that in due course. Either way, I'll be setting up each side of the engine individually before I pipe them together with a common steam inlet pipe. The flywheel grooves are a little bit chattery, but this is quite a difficult thing to machine on a small lathe. I might have a look at that in due course. This is 2 standard flywheels for a Victoria ganged together. When I rotate this flywheel, and do bear in mind there's only one side of the engine fastened to it, there's a really bad tight spot. No matter what I do, no matter where I move the bed plate, it's got a tight spot. So this will need looking into. As neither of these engines are fastened to the bed plate and never have been, there is a possibility that the crankshaft is bent. Already I think I'm committed to pulling this engine right down to its component parts and starting again. Just look at the crosshead. This is a joke. There are clearly packing washers underneath the crosshead top guide bar. So this leads me to believe that maybe the cylinder is not in line with the crosshead. And the noise would be unbelievable if the engine was actually running with the crosshead this slack, not to mention the fact it's a twin, so there are 2 crossheads that would be clacking in unison. I've turned the engine around and you can see here that the crank web's not the right way around at all. Someone's taken the trouble with this engine to taper the guide bars and it looks quite nice. They've made a bit of a mistake by drilling the lower guide bar. This is all simple stuff though and very easy to rectify. The play on the crosshead at this side of the engine makes the other side look okay, and you can clearly see washers underneath both ends of the slide bar. This is no good at all, and as I said earlier, I'm quite concerned about this. At this stage, as a rough guess, I would think that the slide bars are not in the right place to start with. Other things on this engine are pretty good. The brackets that hold the cylinders are very well made, and the cylinders seem to be quite well machined externally. Can't comment until I get inside them to see what the bores are like. It looks to me like the builder of this engine actually had some skill, but lost his way during the build. I see this quite a lot. People seem to get fed up of building engines and rush the last parts, start off very well, then mess up at the end. When it comes to fitting the parts together that you've made for an engine, if the parts aren't made well enough, then the builder's going to have to bodge it when he puts the engine together. Have a look at this, you'll see what I mean. I somehow get the impression on this engine that more than one builder was probably involved, because the meticulous, painstaking finish on the cylinders is not duplicated on the main bearings, and they're not even split. Split main bearings make it possible to adjust the main bearings to take up any wear, and that's what's shown on the original Stuart drawing. This video is called Examination and Diagnosis. I'm not really going to cover fully pulling the engine from together in one video, but I need to have a closer look. So I've removed one side of the engine, and now the flywheels come off the crankshaft. And I can already see some ultraviolence on the eccentric. This will need looking at. I would think there's something a bit wrong there. Or maybe the builder just lost his temper, I don't know. My first findings show that the eccentric is quite firmly stuck on this shaft. It must be a tight fit, so I'll have to look at that. The first thing to take off is the linkage to the valve spindle. I want to test something with this valve spindle, so I'll just remove this linkage first, and I'll put the pin in a safe place, in the plastic box. What I'm going to do now is use some compressed air in the valve chest to see what happens when I move the valve spindle, and this is not encouraging. There's a very limp movement in one direction only, and the piston rod does not return. There is something definitely wrong in the valve chest here. From my experience, if all the nuts and bolts are loose, there's a problem with the engine. Someone's been here before me trying to sort it out. And these are all very loose. Everything's almost a finger-type fit, except the 2 vertical studs that hold the crosshead in place. These needed a bit of attention. Right, that's those removed. The cylinder's unbolted and should come away easily. Time now to have a look at the cylinder. As I've said earlier, it's quite well machined externally, and I'm quite surprised it's not working, but we'll find out what's happening. The port face is damaged, and what I do notice about it, which is a little odd for a Stuart Victoria, I built one many years ago, and the inlets were cored all the way through to the cylinder, which makes the casting very easy to work with. On this engine they're not, and someone has attempted to drill the ports using a very fine drill from the port in the cylinder itself to the inlet port on the valve chest face. So we have a major problem. It's impossible to drill from a cored-in port inside the cylinder to a cored-in port on the valve face without the drill bursting through into the valve face itself, which has happened here. The same thing happens on the other cylinder at the other side of the engine. So I'm going to buy some new castings. One of the cylinders was definitely not good. So I've made a new cylinder, it's all freshly machined, and now I have to use the existing parts and mark out the cylinder for drilling. Marking out the ends of the cylinder using the cylinder covers is pretty straightforward, because the cylinder covers locate on the actual cylinder. But the steam chest doesn't, it wobbles all over the place. So using some Loctite 603, which is bearing retainer, simply stick the steam chest to the port face. Apply the Loctite 603, go and have a cup of tea, and when you come back, the steam chest is stuck firmly enough to the port face to allow you to use the existing holes in the steam chest to make indentations in the port face. What we're going to do is use the indentation as a centre so that when the tapping size drill is used, it's in exactly the right place. Once this is completed, a simple tap with a hammer, not too hard a tap, will separate the steam chest from the port face. Then you can simply scrape off the Loctite 603 with a ruler or something similar. With a suitable tapping size drill fitted, which is a 2mm drill, the first thing I'm going to do is set a depth stop. This will ensure that all the drilled holes are the same length, and this makes it very easy when you fit the studs because all the studs are then the same length. Saves a lot of messing about later. And here we have the cylinder's port face with 6 holes drilled in it, which are all the same length, and now I'm using a tap to tap the holes, but not at this speed. This is speeded up to stop anyone slipping into a coma whilst watching the video. The holes in this casting at this point on the port face are quite deep, so I'm using a taper tap first, and then I follow it straight away with the plug tap to get down to the bottom of the holes. You need to have a touch like a midwife when doing this because it's very easy to break the tap. Here you see a temporary assembly, and everything fits very well indeed. I'm quite pleased with this. After marking the position of the studs on the cylinder casting, using the cylinder covers in a similar way to the steam chest but without any Loctite, it's time to drill the holes as can be seen in the video. I machined the mating surface of the exhaust port using my milling machine, and here I'm using a needle file to draw file the surface just to clean it up and give it a better finish. I'm using the gunmetal exhaust flange to mark out the casting for drilling. Again, I'm using the Loctite principle, just stick it to the casting. When the Loctite's gone off, make slight indentations in the casting, then transfer to the drilling machine and drill all the way down. Again, use the depth stop. And as before, this will make sure that all the studs protrude just the right amount. This centre hole needs to go all the way down to the exhaust port, which is right in the centre. The secret to getting a successful tapped hole in a cast iron cylinder is really to take your time. Make sure of course that you use the correct tapping size drill, but take your time and back off the tap periodically. On another thing, do not ever drop it on the floor with the tap wrench and the tap in the work, it will break off. What I would normally do is give the engine a first coat of paint, and this is the first coat that you see here. This green is not Stuart green. I don't actually like the modern Stuart green colour, so what I do is mix my own. This is Humbrol No. 3 green, with some black added, and the more black that you add, the darker the green gets. I generally do not paint all of the parts. These are the cylinder brackets that hold the cylinders in place, and I don't like them painted. I think they look okay in sort of natural steel colour. A lot of full-size mill engines that I've seen are generally painted green, but they do have a lot of bare metal showing. And yes, it will go rusty, but a bit of oil generally takes care of that. It's not a problem in the model. When I ordered the replacement cylinder castings from Stuart Models, I also ordered some gaskets, and here they are. It's false economy to reuse the old gaskets. Nothing worse than putting the engine back together, spending a load of time to find out that it leaks where the gaskets are. In this shot you can see the studs are in place, and the two missing ones at the bottom are for the countersunk bolts. And here is the cylinder with the covers attached. This cylinder was the one that I remachined, so it's good to see that it moves very freely. No binding, no tight spots, and it's parallel all the way. And here it is fitted to the engine. When building or replacing a cylinder on a Stuart Victoria, it is really important, in fact it's essential, that the port face is perfectly in line with the base. If the cylinder is canted over in either direction, not only will the engine look bad, everything will be very out of line. So if you are building one from scratch, be very careful at the marking out stage of the cylinder for the bolts that mount onto this piece of angle bracket that you have to machine. Making a single Victoria is one thing, making a twin is much more difficult. The two cylinders must be in line with each other. This engine wasn't like this at first. Both of the exhausts came to the outside edge of the engine, and I thought this is not a good idea because it's more difficult to have a common collector. So I've reversed the cylinder that I made, so both of the exhaust ports face each other between the cylinders. But of course, if the cylinders are not in line, getting a pipe to look right is not going to be easy. So here you see me using a piece of 3/16 steel just to show that yes, the ports are perfectly in line, so that when I make the copper exhaust pipes, everything will look very good. Back to the cylinder now. Here I'm applying a liberal coat of steam oil on the port face, because I'm going to fit the slide valve, followed by the steam chest and cover. Make sure when you're playing with a Victoria that you put the slide valve in the right way around. If you put it in the other way, because it's not exactly square, you will not get enough valve travel. I see an awful lot of Stuart models where the slide valve is in the wrong way. Also, make sure that the little cross piece, the brass piece you can see, is not a tight fit in the actual valve. The valve has to float slightly so that steam pressure can hold it onto the face. Quite a routine job this, I've done it many times. The gland's been packed with some graphited yarn, and I'll just put a bit of oil on here. Then all that's left to do is to fit the gasket, followed by the steam chest cover. The studs that hold the steam chest cover in place are only 7BA with 7BA nuts, so be very careful not to shear these off. Do not put too much pressure on at all, just enough to nip them up tight. And now for the exciting part, a compressed air test to make sure that the cylinder actually works. Here we go, I'm sure it's going to work. Now the other cylinder. Yes, everything's fine with both of these, plenty of power. The silicone piston rings are creating a great seal in the cylinder. Now, flush with success because everything works, it's time to do a dummy run on assembly. Both of these parts need to be the same distance away from each other all the way down. But first, it's a good idea to fit the guide bars. The twin crossheads need to be a good fit in the guide bars with no tight spots. And by no tight spots I don't mean a rattle fit. The original builder of this engine fitted everything as a rattle fit, mainly due to the fact that the cylinders were not in line with the bed plate. So now I can get a good fit by simply machining a tiny amount off the two middle spaces and using some shim washers underneath. I'm going to use the old base that the engine was originally mounted on to line everything up. The engine will be screwed to this base for the test running procedure, then it will be removed and fitted to a nice mahogany plinth. Now I know that everything fits okay and works, I need to take the engine apart again, rub down the paintwork, give it another coat of paint, then reassemble the engine for a final setting of the timing and a test run. Thanks for watching, I hope you found it useful. Please take the time to visit my Mainsteam Models website. Click on the section of the website that says Video Playlists. And by doing that, you will find it very easy to find other videos that you may like to watch.